Welcome back to the second part of our blog project. In our next step, we will define Pydantic models. Pydantic is an absolutely irreplaceable library when it comes to backend development, as it allows us to validate and serialize data with very little effort. In the app directory, we are going to create a models.py file, which will host all our Pydantic models. I'm going to import Pydantic base model and field, and from typing module, I will also import list and annotated. Our first model will be called blog post. By inheriting from base model, it will become a Pydantic model, and all of the typing hints will be strictly validated. If you are not familiar with Pydantic, I recommend you check the documentation. It is a big library, but immensely powerful. In this model, I will define title as a string, tags as a list of strings, and content, which will be also a string type. This model will be used for validating the AI-generated blog post structure before inserting it into the database. The last thing we want is for our database to contain unserialized data. We will also define a request model, which will only contain topic as a string. I am going to use the field function with max length parameter, which tells Pydantic to validate the length of the string and throw a validation error if it's longer than 150 characters. With that out of the way, I am going to rename our existing endpoint and add the request model inside of the function, which gets called every time this endpoint is called. By doing this, the request will be always automatically validated by Pydantic, and we don't have to do any more work. Any invalid request which doesn't pass the validation is going to get an HTTP invalid request error. Now I edit the topic parameter for the createBlogspot function we created to the topic variable of the request model. This way we know that only a valid string of maximum of 150 characters is going to get passed into this function. I'm going to go back to our database handler class for a minute to create a function which will insert data into the database. This function will accept a post parameter, which will be the blog post Pydantic model. That way, it is serialized and safe for inserting. However, we cannot directly insert the Pydantic model, so we will simply dump it into Python dictionary. We definitely want a unique identifier for each blog post, so I'm going to add it to the dictionary. And we also want to know when a certain post has been created, so we will include that also using the Python datetime library. Keep in mind to always use UTC time, as Mongo uses UTC for date storage. Finally, we can call the insert1 method and return a Boolean representing if the insert operation was successful. Here we could also return a modified count as integer or the post data itself. In main.py file, I'm going to proceed with the API endpoint. I will import our Pydantic blog post model and validate the response generated by the createBlogspot function. I will save the model in a variable called post. I will also import validation error from Pydantic and catch this error in case the data does not fit the model specification. If this error is raised, I will return a server error response. Your approach might vary. For example, you might want to recursively call the generateBlogspot function again until the result is right, or try something else. Now I'm going to save the serialized post data by calling our database function, and once again throw an error if the post couldn't be saved for some reason. At the end of the function, I will return a 200 HTTP OK response with a success message. Let's try if it works. Okay, great. We received a success message from the API. Let's take a look at our database to see our new post. You can see we have our tags neatly organized in an array. We have our title and the post content just like we wanted. Seems our generation endpoint is working well. Now we need to create an endpoint for listing our posts. I will create a simple HTTP GET endpoint called list posts and specify the response model to be a list of the blog post model. This means that before a response is set to the client, it will be validated against our Pydantic model so that we know exactly what will be the content of the response. In the function, I will specify a request parameter which will be necessary in order to send a HTML template response. I will get our posts by calling the database method listPosts. Since we don't have this method yet, let's create it. I will simply call the find method and append the result to the posts array. I'm going to remove the Mongo document ID from that result because we would have to convert it, and we don't really need it in our case. In the endpoint function, I will simply return a JSON response of the posts array. Let's run and see if it works. It seems we got a server error. Let's take a look at the console to see what the error was. It seems that the error is related to the date time field in our database, specifically the created date. To fix this, we will simply convert it to string by calling the isoformat method on this field. Okay, now it works properly. To implement the template response and return an HTML file from the list endpoint, we will first install Jinja templating engine. Then, we will import Jinja templates from FastAPI templating module. Then, I will create a directory called templates in the root directory of my project. To tell the program where it should look for templates, I will define a variable called templates with the newly created directory. In the templates directory, I will create an HTML file named posts. Here, I will specify a page title, and in the body, I will use a for loop to loop over the list of posts. It will work like this. The API populates the list of posts into the template and will return a fully populated HTML file with our posts. We use the list tag for each post, and then extract the title, content, and tags. We will truncate the content to only the first 50 characters. In the endpoint function, replace JSON response with template response, specify the HTML file, FastAPI request for context, and finally, the array of posts. Now, if we run the API and open the list posts URL in the browser, we see that our posts have been neatly returned as HTML. I'm going to quickly create a new post and refresh the page, and as you can see, everything updates in real time. Okay, so to recapitulate, in our project, we created two endpoints, one for generating post data and the other for listing it. We used Langchain and OpenAI model to generate the post, Pydantic to validate the data, and Mongo DB as our data storage. For listing and displaying posts, we implemented a template response with Jinja templating engine. Hopefully you've learned something new with this project. If yes, don't forget to subscribe for more tutorials coming very soon. Thanks for watching.